Good morning guys, Anjani Kumar here, dealing instrumentation subject for a final year electrical students. Till now we have successfully completed our second unit regarding transducer, alright? In this session we are going to discuss about a brief review on the whole content that what we discussed till now under transducer concepts. Each and every time why I'm taking a brief session at the end of each and every unit means I think you peoples are very busy with your works, right? It's very difficult for you to see the videos that all faculty members sending through a WhatsApp and whatever it may be, right? So it might be very helpful for you by providing these type of brief session under completion of each and every unit. So it will be very helpful and you'll get a brief idea about all the unit. So that's what I am taking a brief review on after completion of each and every unit. So like that today's session also I'm taking the brief review on the transducer concepts. Right. In a transducer, first we discussed about what is a transducer. So what is a transducer? Transducer is a device which converts a non-electrical quantity into electrical quantity. So we can call it as a transducer. Right. So basically nowadays we are using electrical transducer. So for suppose if you have a temperature, you have a liquid flow, you just want to find out the torque, you just want to find out the pressure. So these are the non-electrical quantities. It's very difficult. We don't have any methods to find out the torque measurements directly. Temperature, liquid flow, it's very difficult for you to find these type of non-electrical quantities. So for this we have a instrument called a transducer, which convert all the non-electrical quantity into electrical quantity, not only electrical quantity. Alright, so the transducer is a device which converts one form of energy to another form of energy. So basically we are using instruments, all the instruments are operated with the help of electrical supply. That's why we are converting all the non-electrical quantities into electrical quantities, because that electrical quantity might be useful for other instrument to operate. Alright, so that is the definition of a transducer. I just want to repeat it. The transducer is a device which converts a non-electrical quantity into electrical quantity. Alright. So what, and after that we discussed about some examples also. You just want to just go there and see that sessions, right? And after that we discussed about different parts in a transducer. So basically there are two parts in a transducer. The first one is a sensor and second one is a transduction element. Alright. So the sensor, which sense, so what is the non-electrical quantity that we are getting. Alright. So the transduction is the heart of a transducer, which will convert the non-electrical signals into electrical signals. Right. So basically all the sensor are a transducer, because all the sensor or transducer, but some devices is there, they won't have a sensor. The transduction elements itself, it will convert a non-electrical quantity into electrical quantity, right? So from this you will say that all the sensor is a transducer, no doubt about that, but all the transducers not the sensor. Remind, it's very important bit that you got last polytechnic examinations. Right? All the sensor is a transducer, but all the transducer not a sensor. Examples, you know, thermocouple, thermistor doesn't have any sensor. The transduction element itself, it will act as a sensor on a transduction. Alright. Then after that we discussed about each and every transducer, that it has some characteristics. Alright. So what are the characteristics of a transducer? Right. So transducer is nothing but an instrument. So whatever the instrument characteristics will be replaced to a transducers also. So there are two types of characteristics: static characteristics and dynamic characteristics. In that static characteristics, it doesn't vary with the time, right? So in that static characteristics, we have a desirable, undesirable static characteristics. You know everything. The static characteristics are accuracy, precision, resolution, linearity, sensitivity, repeatability, reproducibility. These are desirable characteristics. Undesirable characteristics are hysteresis, drift, zero drift, span drift, all these things, right? That we discussed in detail, right? After that, dynamic characteristics. So those are speed of a response, fidelity, and dynamic error constants, right? So these are the dynamic characteristics. These are the total characteristics of a transducer, right? After that, we discussed about different transducers is there. So each and every transducer that it has some characteristics, right? In that, what type of transducer you are going to select? So that we discussed about choice of selection of transducer. So there are different things that we need to consider by selecting this transducer for our operation and all these things. The first one is based on working principle, right? So what is you are using to find out the resistance? We just go for a resistive transducer based on working principle. If it is an inductive principle, you just go for inductive transducer. If there is a capacitive principle, go for a capacitive type transducer. So based on working principle, you need to go and select the transducer. And the transducer having a good sensitivity, high sensitivity, that's type of transducer you are going to select, which is having high accuracy, right? The deviation from output to input, it should be very small range, right? That means high accuracy type of instrument, type of transducer you are going to choose. After that, whatever the error from output to input, very less. So those type of transducer you are going to select, right? You are going to select the transducer which is having which can be protected by the external electrical field. That means temperature. It can be protected from the environmental condition, right? Whatever the stress from the electrical and magnetic fields, stray magnetic fields, it can withstand. It can withstand from the vibrations also, right? It can be reduced by a less loading effect also. Those type of factors we need to consider while selecting a transducer, right? Based on working principle, high sensitivity, accuracy, environmental condition. It should be withstand the vibrations also, and it should be error should be very less. The loading effect should be very less. All right. So these are the choice. These are the selection factor while choosing. This type of transducer used for this type of operation and all this thing. Right. After that, we discussed about advantages of a transducer. So what are the advantages of a transducer? You know everything. So the transducer, the output is nothing but electrical signal. So whatever the electrical signal coming out from the transducer, it should be easily attenuated and easily amplified. A small minimum value of electrical signal that we are getting, right? After that, these type of transducers are very less in size, right? After that, whatever the electrical signal that coming out from the transducer, it can be transferred for a long distance also, right? So whatever the sensor in a transducer that can be operated with the help of a remote with wireless communication system, right? So it is in a very less size. Environmental conditions very less affected with the environmental conditions also. So these are the advantages that we discussed about transducer. So what are the advantages? Whatever the electrical signal, it can be easily attenuated and easily amplified, right? It doesn't have any rotating part, so there is no friction, right? There is no wear and tear, there is no mechanical, there is no friction, losses are very less. After that, whatever the electrical signal coming out from the transducer, it can be transferred for a long distance with the help of some digital techniques, right? So whatever the electrical signal that coming out from the transducer, it can be stored for a long time also, right? So these are in a less size, right? So whatever the environmental effect should be very less. So these are the advantages, right? Whatever the sensor that used in a transducer that can be operated with the help of remote for long distance also with the help of wireless communications. Right? These are the advantages of a transducer. Right? After that, we discussed about different types of a transducer. Basically, there are 4 types of a transducer. The first one is active transducer, passive transducer. Second one is a primary transducer, secondary transducer, and the third one is analog transducer, digital transducer, and the fourth one is electrical transducer or inverse transducer. So these are the 4 categories in a transducer, right? But in our syllabus, only active and passive transducer we are going to discuss it. Reminding we don't have that much content. But I just give brief explanation. I have given a brief explanation of all the different types. Right? So what is active transducer? This type of transducer that doesn't require external auxiliary supply for its operation of transducer. It doesn't require any external supply for its operation. Right? What is a passive transducer? Means it requires operation. It requires auxiliary supply for its operation, for its conversion from non-electrical to electrical. So those are passive type transducer. So there are passive type. We have a resistive, inductive, and capacitive type is there. Right? After that, analog and digital transducer. So what is analog transducer? Whatever the electrical signal that coming out from the transducer is in analog nature, right? Positive, negative, sine wave or cosine wave form. Right? What is a digital transducer? Whatever the electrical signal that coming out from the transducer, it's nothing but a pulse, discrete values. Right? After that, primary transducer and the secondary transducer. Primary transducer means in a single step we will get the electrical signal. For suppose if you want to find out the pressure, directly pressure is converted to electrical signal. Right? That is a primary transducer. Secondary transducer means doesn't in a single step, 2 steps you will get the result. Pressure is converted to displacement. Again, displacement is converted to voltage. Pressure is converted to displacement with the help of Borden tube. Displacement is converted to voltage with the help of LVDT. So LVDT works as a secondary transducer. Right? Only single transducer if you work, it will act as a primary transducer. 2 transducer, after end of the second transducer you get the electrical signal, that means that is a secondary transducer. Right? These are the basic things of different types of a transducer. Alright. So after that we discussed about in our syllabus the passive transducer. Alright. So what is a passive transducer? You know everything. Passive transducer means it's require auxiliary supply for its operation. For a transducer operation, it requires external electrical supply. So there are 3 types of a passive transducer. So that is our resistive transducer, inductive transducer, capacitive transducer. Right? So what is a resistive transducer? So whatever the non-electrical quantity that can be measured, that can be found by measuring the changing the resistance. Alright? So whatever the non-electrical quantity can be found out by measuring the changing the resistance. So these type of transducers we can call it as a resistive transducer. Right? We discussed about the potentiometer resistive transducer. Right? One knob is there now. If you move that knob, right, one sliding wire is connected between the resistance. Right? If you move that sliding wire, the displacement will be changed. If you change the displacement, definitely the resistance value will be changed. Right? So whatever the change in resistance you can find out with the help of a meter, with the help of beats and bridge. So whatever the voltage that you are getting, which is analogous to the movement, the displacement that you applied. Right? The potentiometer, if you go for a potentiometer, one sliding wire is there. So initially the sliding wire at 0 position. So total resistance will be in a supply. Alright. So when move your sliding wire, the displacement will change now. Alright. So with that your resistance will change now. Your resistance is directly we can find out with the help of a voltmeter. So whatever the voltage across this resistance you can find with the help of voltmeter or a Wheatstone bridge. Alright. So then you will get the voltage. How the voltage came? So the voltage which is analogous to the displacement that you applied. Right. So that means your linear displacement which is converted to voltage. So this is like a transducer. After that, bridged and bridge type resistive transducer. Under the bridge balance condition, whatever the galvanometer will reach the zero deflection, right? So whenever the change in resistance happen, definitely the bridge will unbalance. It will show some voltage. So whatever the voltage that you are getting in a bridged and bridge, so that is analogous to the change in resistance that you applied. So whatever the change in resistance, how you got a change in resistance? By varying a displacement. So displacement which is directly proportional to the voltage that you are getting in a Wheatstone bridge. So this is another model, right? If you directly place a voltmeter, you will get the change in resistance, right? You can measure the change in resistance. Or with the help of Wheatstone bridge, whatever the change in resistance that you applied one bridge, one arm, definitely the meter will unbalance. It will show the voltage. So whatever the voltage that you are getting, which is analogous to the displacement. That's a brief concept regarding resistive trend. Then after that we discussed about RTD, resistive temperature detector, right? So it is used to measure the change in temperature in a metal by measuring the changing resistance, right? So we clearly discussed about these things. It's nothing but the metal which is used with a positive temperature coefficient. When a temperature increases, what happens? The resistance will be increases. The change in resistance, it can be measured with the help of a voltmeter or a Wheatstone bridge. So then how much amount of temperature change you can easily find out. Basically metals, we are using a platinum metal which is a positive temperature coefficient, right? The construction is nothing but simple one metal, platinum metal is there. Whatever the unknown temperature you just applied at the second end, so with the help of temperature, the platinum metal resistance will be changed. You can find the change in resistance. That's simple construction we discussed in detail with a neat sketch and all these things. If you have any doubts, you just go and see that construction itself. After that, we discussed about inductive transducers. So what is inductive transducer? You know that whatever the non-electrical quantity, if you want to measure by measuring the change in inductance. That's it. Simple logic is changing the physical parameters itself in a passive transducer. If it is a resistive, resistance will change. If it is inductive, inductance will change. Nothing is there. Alright. So how you are getting a change in inductance? The first directly won't get the change in inductance. First you have to change the flux. Then only the inductance will change. The change in inductance you can measure with the help of a voltmeter or whatever it may be, deflection meter, moving coil meter, whatever it may be. Right? So basically there are two types of inductive transducers. The first one is a one coil inductive transducer, that is nothing but a self-inductance. Right? Second one is a two coil inductive transducer, that is called mutual inductive transducers. Right? In a one coil inductive transducer, you have two magnets which are connected in parallel. One magnet which is having a coil is excited by the AC supply. Alright. Another magnet placed bottom of the first magnet. Right. So between two magnets you have an air gap. Right. Whenever AC supply is applied to the coil, what happens? Coil gets excited. There will be a flux generated. Right. You have a bottom magnet now. You are giving a motion to the magnet, either up or down. So giving a motion means your air gap will change. Change in air gap means it will create a change in flux. Change in flux is created means the inductance of the metal coil will be changed. That inductance you can find out with the help of calibrated moving coil meters, right? So that is converted moving coil meter, moving coil voltmeter. So that will reach the voltage. How you are getting the voltage? When you apply a motion, whatever the voltage that you are getting, which is analogous to the motion that you applied on the second magnet, right? So that means the motion is directly converted to voltage. You don't have any methods to find out the motion, right? So with the help of transducer, it will be very easy for you guys, right? So whatever the voltage that you are getting, it will be helpful for another instrument should operate, right? Nowadays, all the instruments that require like electrical supply. Right, so this is a one coil inductive transducer that we discussed, and after that we discussed about two coil inductive transducer. So what is a two coil inductive transducer? Similar construction. It is having two magnets which are connected in parallel. So one magnet two magnets. So one side of a top magnet you have a coil which is excited by the AC supply. There will be air gap between the two magnets. When it's excited by the AC supply, what happened? There will be a flux will be developed. When you move the motion, there will be a air gap changes between the two magnets. Due to the change in air gap, the flux will change. Change in flux will travels another coil, right? So there will be a EMF developed in another coil. So that is called mutually induced EMF, right? So whatever the EMF that you are getting another coil, so which is analogous to the motion that you applied. So that means the change in flux you are getting by applying a motion. So whatever the inductance, you will find out the voltage. Alright, hope it's clear. The motion, how it's directly converted to electrical signal, voltage, whatever it may be. So that we can call it as an inductive transducer, right? After that we discussed about capacitive transducer. So what is a capacitive transducer? The name itself indicates we can find your non-electrical quantity by measuring the change in capacitance, right? Change in capacitance, right? How you are getting a change in capacitance? So what is a capacitance? When two parallel plates which are separated by a dielectric medium called air, when a voltage is applied, so there will be a charge accumulated in each and every plates, right? One plate positive charge, another plate negative charge, right? So how much charge accumulated, that much capacity existence in the system, right? So how we can get the change in capacitance means C is equal to epsilon A by D. You know the values, right? Epsilon is nothing but dielectric constant with the permeability. A is nothing but area of the plates. D is nothing but distance between the plate. If you are changing these things, the capacitance will change. The change in capacitance you can find out the meters, voltmeter, right? You don't have a separate method to find out the dielectric strength of something, and you don't have find the distance between the two plates. If you vary a distance between the two plates, your capacitance will be changed. It is nothing but a capacitive transducer, right? Finding the distance or a linear displacement which is converted to voltage, right? Area, we don't have methods to find out the area, epsilon, and all these things, right? So how each and everything we explained in detail, right? How the capacitance will change by changing the dielectric material, right? By changing the distance between the plates. By changing the distance between the plates, you will get the non-linear scale. So for this, we have a equipment called differential capacitive arrangements. With that, you will get the scale is a linear, right? After that, how area changes between the plates, area changes, definitely the capacitance will be changes. The change in capacitance you can find out with the help of voltages also. These are the different methods by changing your capacitance, right? So definitely the plates, whatever the plates that you are using in a capacitance, that can be a cylindrical type, depends on a pressure requirement. If it is high pressure, those are cylindrical type requirement. You can take this one, right? So this is about a capacitive transducer. First you have to know on what basis you are changing capacitance. That's it. With this, you can easily find out the change in capacitance. That can be found out with the help of voltmeter and calibrated scale also. After that, we discussed about LVDT. So what is LVDT means? Linear variable differential transformer, right? So it is used to find out the displacement, right? The displacement, it is nothing but inductive transducer. Alright, so why we can call it as, I will explain the name itself, linear variable differential transformer. So what is a transformer? Like a transformer, it is having a primary and two secondary coils. Alright, that's why we are calling a transformer. Differential, whatever the output that you are getting from the transducer, it's nothing but a difference between the difference in a secondary coils, right? Whatever the voltage difference in a secondary coils. Linear variable, whatever the displacement that is linearly vary with output voltage. So that's linear variable differential transformer. So it's a simple construction. It consists of one primary winding and two secondary windings, right? Whatever the soft iron which is placed initially at middle point of the circuit, right? So primary is going to be energized by the AC supply. So definitely the flux will be generated. These flux links with the secondary, it produces the EMFs E1 and E2. So initially at the center, soft iron pieces at the center. So whatever the voltage, because those two secondaries are same number of turns, same displacement, right, from the primary. Then whatever the voltage that you are getting, E1 and E2, both are equal, right, at X is equal to 0 position of a soft iron piece. So the change in voltage, that should be a 0, right, displacement is 0, your change in voltage is 0. Now you move your soft iron piece to the left side. So definitely what happened, the change in flux in a E1 secondary transducer S1, it should be very high when compared to S2. That means whatever the voltage that you are getting in S1, E1 should be very high when compared to E2. So whatever the delta change in voltage, delta E, it should be a positive, E1 minus E2. So that means E1 greater than E2. So how you are getting change in voltage? By measuring, by applying a displacement from a left side. When you move a displacement right side, so whatever the change in flux in a secondary coil, it should be very high. That means voltage generated in a secondary, it should be very high. That means E2 greater than E1. So whatever the change in voltage, you are getting a negative. So you are getting a negative means you are getting a positive in when move left side, means whatever the voltage, whatever the change in voltage that you are getting, which is same pattern of applied voltage, right, you are getting a negative from a right side, means whatever the voltage, change in voltage that you are getting, which is analogous to the which is reverse phase difference, right, reverse phase difference with the applied voltage. That's a simple trick that you need to understand. I hope it's clear, right? So this is about LVDT. There are some advantages and disadvantages also there. The change in flux, you are getting this is nothing but a passive transducer. Without external electrical supply, it won't operate, right? Different construction details that we discussed in detail, right? So after that we discussed about strain gauge. So strain gauge, what is meant by strain gauge? So first you know the definition of what is meant by strain and stress. So first, stress. So what is meant by stress? Stress is nothing but force per unit area. Stress is nothing but how much stress on it. That means how much force that you are inserted per a particular area, right? Force per unit area, we can call it as a stress. What is meant by strain? Strain is nothing but extension of a length. Strain is nothing but pushing, right? Pulling or pushing, whatever it may be, right? Extension of length. So delta L by L, we can call it as a strain. Original length is L, change in length is delta L, right? Stress is nothing but force per unit area, F by A. Hope it's clear. So what is a strain gauge? Strain gauge, which is used to measure the, which is used to when a metal is stretched or compressed, the resistance will be changed, right? So this is a working principle of a strain gauge. Strain gauge, which is used to measure the strain or stress which is converted to non-electrical quantity. How it can work means whenever the metal which are stressed or compressed, the resistance will be changed. This is a working principle of a strain gauge. One metal is there, right? One metal is there. When you stress or compress, definitely the length will change. Due to that length, the resistance will be changed. By changing the resistance, you can find out with the help of Wheatstone bridge or calibrated scales, right? So whatever the voltage that you are getting, the strain or stress that you apply, the similar principle how the strain gauge will work. But in this we have to understand the metals what we are using, how the resistance will be changed. It depends on a gauge factor, right? So what is a gauge factor? Gauge factor is defined as change in length by change in resistance, or change in resistance by change in length. So delta R by R by delta L by L, we can call it as a gauge factor. It's nothing but sensitivity, right? Metal sensitivity will define like a gauge factor, right? How you are getting change in resistance for a metal means by changing the length of the conductor, by changing the cross sectional area, by changing the resistivity of the metals. So with that we can change the resistance of the metal. The resistance you can find out that whatever the voltage that you are getting is analogous to the stress that you applied, right? So after that we derived equation for gauge factor also, that is called 1 plus 2 gamma plus delta rho by stress, right, epsilon, whatever it might be, right. So that 1 represent the change in resistance due to change in length, plus 2 gamma is nothing but Poisson's ratio that we discussed in detail over there. 2 gamma represent the change in resistance due to the cross sectional area of the conductor, or delta rho by epsilon, it represents the resistivity changing due to change in resistance, right. So these are the factors that we discussed in detail under strain gauge concept, right. So definitely the importance of the strain gauge is the need on a bridge balance conditions. Is there any faults? Is there any things, the bridge damage conditions? We can easily find out with the help of the strain gauges, right? We discussed in detail about that. You just go and watch the video, right? So after that we discussed about the active transducer, that is called a thermocouple, okay? So what is a thermocouple? So thermocouple is nothing but active transducer which is used to measure the temperature, change in temperature in a metal, alright. So when two dissimilar metals which are joined together, it forms a two junctions. So one junction we can call it as a cold junction, that is called a reference junction. Another junction we can call it as a hot junction. So whatever the temperature that you applied across the hot junction, so then what happened, the change in temperature will produces the current, right. So this current will enter into the coil, is a moving coil. This will make a deflection, right. So it will reach the voltage. So whatever the voltage you are getting, so that is by changing temperature. That means the principle is the voltage that you are getting by changing the temperature, the EMF is induced, right. Definitely there will be 3 laws associated with Seebeck effect, Thomson effect, Peltier effect, right. You know everything about Seebeck effect. Means it said that definitely when two dissimilar metals are joined together, EMF is generated. How the EMF is generated, he won't tell, right. He didn't tell that one. And Peltier effect means, so definitely the change in temperature only the EMF is generated. And Thomson effect is that this EMF can move over the length of the line, right. At any point you can find the EMF value, right. So after that we discussed about the relationship between changing temperature and the changing the temperature and the voltage, right. So you know E is equal to A delta theta plus B delta theta square. So whatever the metals that you are choosing, the B value is going to be very less. So that means E is directly proportional to A delta theta, right. Delta theta is directly proportional to U. So whatever the volt scale, you are getting a linear scale also. So different types of metals that you know, iron constant and right, copper constant and aluminum constant, and different metals that you can use in case of thermocouples. So that is about the thermocouple. Next we will discuss about a thermistor. The thermistor is nothing but resistive temperature, right, thermal resistor, right. It's nothing but RTD. RTD is a thermistor, right. It is used to measure the temperature by measuring the change in resistance, that's it. RTD is also thermistor, but thermistors are two types: the positive temperature coefficient thermistor, negative temperature coefficient thermistor. So the positive temperature coefficient means whatever the temperature is directly proportional to the resistance that you are varying. That means increases, temperature increases, the resistance increases. That's in RTD, right. But in NTC, negative temperature coefficient, the thermistor also are negative temperature coefficients. That means whatever the temperature increases, the resistance will be reduces, right. So all the thermistors are negative temperature coefficient, and whatever the metals, here the platinum metals that can be used, because the metals exhibits the property of positive temperature. Here we are using semiconductor materials, so these exhibits a negative temperature coefficients. So that's why you are using a semiconductor like gallium, arsenic, manganese. So these type of metals that you can use in a thermistor. So depends on operation. Thermistor different shapes: sped shape, bed shaped, disc shaped, and spherical shaped also. Right. uh, basic principle is nothing but whatever the temperature if you want to find, you can apply it. Then resistance length will be changed, resistance will be the resistance, you can easily find out. It's a simple operation, right? After that we discussed about what you call piezoelectric transducer, right? So what is meant by piezoelectric transducer? Piezo means squeezing. When squeeze a crystal, so there will be a charge accumulated, right? When pushing, squeezing, nothing but force that you applied on a crystal. So what type of crystal? You are using natural, right? Synthetic crystal also is there, but we are using a quartz crystal. When squeeze on a quartz crystal, definitely the charge will be accumulated, right? So this charge, the charge that you are getting, piezo means squeezing, electric means charge, right? So whatever the charge is nothing but current, squeeze is nothing but force. When the force applied, the current will be generated. This current can be measured with the help of calibrated scale, so we can get the voltage, whatever the voltage that you are getting, which is applied the force or stress that you are getting, right? But whatever the charge accumulated on the crystal is very small, right? Small current will be flow. This current is going to be increased by the help of amplification. So this current will enter into the moving coil arrangement, so thereby the deflection will changes. It will reach the whatever the voltage that I generated, right? So whatever the force that you are applied, always a dynamically force, not use a statically force. If you use a static force, that means if you squeeze single time, definitely what happens, the charge is accumulated, that won't move. So if that charge won't move, there is no current. So what if there is no current means there is no voltage. Whatever the force that you are applied is a dynamically force, right? So that charge is directly proportional to the current or voltage that you are getting, right? So then develop the charge sensitivity. This charge sensitivity will depends on how much direction that you are applied, right? The direction of force that you are applied depends on charge sensitivity, right? So after that, how with the relation, we derive the relationship between the voltage and the pressure that you applied. So E is equal to ZPT. So E is nothing but applied developed voltage, G is nothing but voltage sensitivity, and P is nothing but pressure you applied, T is nothing but thickness of the crystal. Alright, so we derived very important equation that we derived in our class. Right, E is equal to GPT. It's very important equation. After that, finally we discussed about a simple synchro transducer. You know about synchro. Synchro is nothing but angular displacement of a rotor which is converted to voltage. It consists of a synchro transmitter and a synchro receiver. Alright, we have a arrangement called a rotor which is excited by the AC supply. Alright, so rotor which is connected to the shaft. Right, the positions you will check it out. Right, whenever the rotor rotates, rotating magnetic field will be developed that will enter into the stator. By the stator, each and every coil is connected by the voltmeter. Right, the position changes, the voltage will be changes. Right, E is equal to E1 cos of theta plus 120 sin omega t. So a theta represents the position. If you change the position, whatever the voltage E1, E2 will change, right? How you are getting a changing voltage? By changing the position. That means whatever the angular displacement which is converted to voltage, right? So this is about the total content regards the transducers, right? I hope it's clear. If you have any doubts regarding this transducer session, feel free to call me. Definitely I will solve your problems, I will solve your questions, right? Alright, and it's about a transducer. In the next session we will start digital voltmeters. Alright, so what are the digital what is a voltmeter, what are the different types of voltmeter, why we are using a digital voltmeters, right? After that we discussed about different types of digital voltmeter, right? All these things, successive approximation is there, ramp type is there, continuous balance type is there, alright, frequency meter is there, digital phase meter is there, right? These are microprocessor based digital voltmeter is there. So we are going to discuss all the digital voltmeter in coming sessions. I hope that you people are following my videos, right? stay safe, stay home. At least once you should watch all of our faculty's videos, right? It will be very good for you and for us also. Thank you for now.